I want to show a couple rational function limits that students often make mistakes on because the denominator goes to zero, therefore the assumption is that the limit does not exist. So we have to be really careful with that. So here's an example. Look at the limit as x approaches 8 of x squared minus 10 over x minus 8. And if we were to do direct substitution and plug 8 in, we would get 54 over 0. That does not mean the limit doesn't exist. That means we need to look at the two-sided limits. Just because the function doesn't have an output at 8 doesn't mean the limit doesn't exist, because the definition of a limit is what happens as you get infinitely close to 8. So let's look at the limit as x approaches 8 from the left of this function. And what happens in this case is, well, it doesn't matter if you approach 8 from the left or the right. When you square it, you're going to get something really close to 64. Now on the bottom, if we plug in 8 from the left, we're going to get something really close to 0, because something close to 8 minus 8 is close to 0. But since it's a number slightly less than 8, we're not actually going to get 0. We need to understand that in the denominator. On the top, since we get 54 for 64 minus 10, really close to 54 or equal to 54 is going to work just fine as far as limits. But when we divide by 0, we have to be more careful. So if x is a number slightly to the left of 8, maybe like 7.99, and you do the subtraction, you're going to get a number close to 0, but not quite 0. You're going to get a number that's negative and really close to 0. So I'll indicate that with a negative superscript. And so now what we have to think about is, all right, we have 54 divided by a really tiny negative number. You know, you might think of, just to visualize this, you could think of it as negative 0.01, or negative, to be even more extreme, several zeros followed by a 1. And the goal here is to understand the behavior of this. If you divide 54, which is a positive number, by a really tiny negative number, you're going to get a really big negative number. So the left-sided limit is negative infinity. Similarly, if you look at the right-sided limit, you're going to get 64 minus 10 on top again. But now when you plug in a number slightly bigger than 8 for x, the denominator is going to be 0, but a number that's positive and close to 0. And so we end up with 54 divided by a really tiny positive number, which is going to give us a really big positive number. Now, the left-sided limit's negative infinity, while the right-sided limit is positive infinity. So that implies that the two-sided limit, notice on my notation here, I'm being very careful with my notation, except that I wrote infinity instead of 8. I bet you've never made that mistake before. The limit as x approaches 8 of x squared minus 10 over x minus 8. Well, that two-sided limit does not exist. But it doesn't not exist because of the 0 in the denominator. It's because the two one-sided limits aren't the same. Okay, so let's look at another similar example with a different outcome. So similar function, but I'm going to put the denominator inside absolute value, inside an absolute value. So hopefully in this case you can see, all right, if I try to plug in 8, I'll get 0 on the bottom, so I can't do that. So I need to look at the one-sided limits. And now on the top, we're going to get 54 again, but on the bottom, I'm going to get a negative number really close to 0 inside the absolute value symbols. And when I simplify the absolute value of a negative number, I'm going to get the resulting positive version. So in this case, the left-sided limit is going to be positive infinity. Let's look at the right-sided limit. We get 54 over the absolute value of a tiny positive number. Well, since that's already positive, it just stays the same when you take the absolute value, and in this case we get positive infinity. Now the two one-sided limits are both positive infinity. Therefore our two-sided limit, as x approaches 8, of x squared minus 10 over the absolute value of x minus 8 is also positive infinity. And lots of times we don't write the positive, but I'm just doing that for emphasis here. So the first limit didn't exist because the two one-sided limits weren't equal, but the second one does exist and it's positive infinity. Now it's not a finite limit, it is an infinite limit. Keep that straight. Okay, but we can do the second one while the first one has two different one-sided limits.